Chapter 6 Application of Derivatives Exercise 6.2 10th question. Prove that the logarithmic function is increasing on 0 to infinity. So we have given the function is a logarithmic function. So we can write f of x is equal to log x. The domain of f is from 0 to infinity. So we can write f of x is a differentiable function. Now, what is f dash of x? That is d by dx of log x, that is 1 by x. So, it is from the interval 0 to infinity. So, when x belongs to the interval 0 to infinity, we have f dash of x is equal to 1 by x is a positive quantity there. So, 1 by positive, that is positive quantity. So, f dash of x is a positive quantity. So, we can write from there f of x is strictly increasing function on the interval 0 to infinity. Chapter 6 Application of Derivatives Exercise 6.2 11th question. Prove that the function f given by f of x is equal to x square minus x plus 1 is neither strictly increasing nor decreasing on minus 1 to 1. So we have given the function f of x which is equal to x square minus x plus 1. So x square minus x plus 1, it is a polynomial function. So we can write that f of x is a continuous and differentiable function in R. So what is f dash of x? That is d by dx of x square minus x plus 1. So what is d by dx of x square? That is 2x. D by dx of minus x, that is minus 1. D by dx of 1, 0. So we have 2x minus 1, or 2 is taken outside. So we have f dash of x is equal to 2 into x minus 1 by 2. When f dash of x is equal to 0, we can write 2 into x minus 1 by 2 is equal to 0. So the value for x becomes 1 by 2 there. So the domain of f of x is from the interval minus 1 to 1, right? So we will be drawing a line segment from minus 1 to 1. So we will be marking a point 1 by 2 on the line segment. So we will be having the splitting the line segment into the disjoint intervals. We have the open intervals, that is from minus 1 to 1 by 2 and 1 by 2 to 1. So these are the intervals we are having. So when x belongs to the first interval, that is from minus 1 to 1 by 2, we will have the equation for f dash of x, that is x square, that is 2 into x minus 1 by 2. So in between minus 1 to 1 by 2, we are applying any value for x. We have 2 into a negative value, that is means negative value itself. So we have f dash of x as a negative value. So f of x is decreasing in the interval minus 1 to 1 by 2. Now when x belongs to the next interval, that is from 1 by 2 to 1, we have f dash of x, that is 2 into x minus 1 by 2. Again we are applying a value in between 1 by 2 to 1. We have 2 into the x minus 1 by 2 becomes a positive quantity. 2 into positive quantity, that is positive quantity itself. So f dash of x is a positive quantity. So f of x is increasing in the interval 1 by 2 to 1. So in conclusion, we can say that f of x is increasing in the interval 1 by 2 to 1 and decreasing in the interval minus 1 to 1 by 2. So from this minus 1 to 1 interval, f of x is neither increasing nor decreasing.